In this video, we are going to take a look at a very important concept in Elixir. This concept is going to make your code look a lot more readable, and it's going to make your life a lot easier when debugging your code. It's also going to make your code look a lot prettier, and this is something that is not available in any other language. So let's go ahead and take a look at this using a case study. So our goal is to take a list, so any list as input, and find the square of the sum of its tail, right? So we have to find the tail, we have to sum it, and then we have to take the square of the sum, right? So the idea is, given square of sum of tails, so this is our function 1 2 4. What we're going to do is find the tail 2 and 4, then sum it and then square it. So in Python, typically what you would do is something that looks like this, right? So here you go. You're going to have a function tail that is going to extract the tail from this list. It's going to put it in A, then we're going to sum A, and then we're going to square A. So this is one method. You can also go ahead and do it using just a single line, and that would look something like this. So tail of A, and then sum of it, and then square. Now both of these have problems. Here the problem is that we are writing this A again and again and again, and this leads to typos very quickly, and it's a lot of work. The second thing is a lot easier to write, but it's a lot difficult to read. If somebody comes along, they have to know that they have to first read this A and then read backwards. So in order to read this line, you start from this A and then you go backwards. Tail, sum, square. What if we could combine the benefits of the readability of this guy with the ease of writing and typo-free manner of this guy, right? So that's the goal. We are going to write this code in a way that is going to reduce the repetition of A, and it's going to make it readable just as it's readable over here, right? So let's start doing this in Elixir. So let's create a new file. Let's save this as 06pipe.exs. Let's create a module. So def module pipe test, right? So you'll know why we are naming this as pipe test. In this module, we're going to first have a function. So that's square. So that's very easy. It takes a number x and returns, so comma do, it returns x into x. So that's a simple square. That's easy. The second function that we need to define is the sum function. So let's go ahead and do that. So def sum, and we are going to take a list, and then we are also going to take a starting value. So let's call that start and 2. I'll explain why we are taking the start value in a minute. We don't really need it, but what we're going to do is we're going to set the default value as 0. So if you want to start, for instance, counting or summing from 5, you can do that as well. But if not, you are going to start from 0. So we can say start plus enum.sum of L. So this enum is a module which is for enumerator, and it can sum over lists for you, right? So enum.sum L is going to compute the sum for us, and we are going to add start to it, right? So let's go ahead and call this just to clarify. So we can say io.puts pipe test.sum, and we can say a list of 1 2 and 5, and starting from the value of 2, right? So this should be 1 plus 2 3 plus 5 8 plus 2 10, right? So this should be 10. Let's go ahead and execute this. So there you go, 10. If we skip this 2, we are going to get 8 out of it, right? So that works. Finally, what we want to do, because we now have the square and the sum, and the tail function is already available as TL for us, right? So we can always get the tail using the TL function as we saw earlier on. So now let's go ahead and write our original function, which is supposed to do this, to take a list as input and find the square of the sum of its tail, right? So we need to find the tail first, then we need to sum it, and then we need to find the square, right? So let's go ahead and do this. So def sst the list do. What we're going to do is we're going to take the list. So the list, essentially what this is going to do is execute the list and return this whole thing back. So you get the list back, nothing important going on at the moment. You just get the list back, and then you pipe it to a function. So what this does is takes this list value and gives it as the first argument to TL. So what TL gets is the list, right? So this is going to return the tail. Now once you get the tail, you pipe it to the sum function, and once you do that, you get the sum of it back, and you pipe that to the square function. So you get the list, You pass it as the first argument of tail, you get the tail back. You pass that, which is the tail, to the first argument of sum. So this is going to go into L and you get the sum of it back. And then when you get the sum back, you pass it as the first argument of square, which is going to be X, and you're going to get the square back. So let's go ahead and execute this. So SST, and this should return 2 plus 5 is 7, and 7 into 7 is 49. So that's what we're expecting. So let's go ahead and execute this and we get 49 back. Now, what's really important over here is to note that we have a very readable piece of code. So we're taking the list, we're passing it through TL, we're passing the result through sum, and then we're passing the result through square. So this is a very powerful concept and it makes your code look really readable. You can read from top down and you don't have to worry about the intermediate variables because you're not concerned with them. Whatever intermediate comes out goes to tail, and whatever comes out from that goes to sum, and whatever comes out of that goes to the square. And at the end, you get the result of the square back. That's a very powerful concept. Now, we can also pass this second argument to sum by simply enclosing this as 2, right? So now, even though this looks like the sum is taking one argument, but it's essentially going to take two arguments. One is going to come out of tail. So that is going to be the first argument, and this 2 that you see over here is going to go to the second argument. This guy over here is called the pipe operator, and this is going to come up again and again, and once you start using it, you're going to fall in love with this. It's extremely beautiful and it makes your code look really, really good, right? So let's go ahead and execute this just to make sure that we understand what's happening. So we get 81 out of this. How is that? We get 1 to 5, 2 and 5 are returned by tail. That goes into the sum. What we do is we do enum.sum. So that is going to be 2 plus 5 of 7. And then we add 2 with it, and that is going to turn this into a 9. And 9 squared is going to be 81. So that's what result we get out of it. So to recap, you take this value, you pipe it to this function, which means pass it as the first argument of this function. Whatever comes back goes into this guy, which means pass it as the first argument to sum. Whatever comes back of this goes as the first argument of square. Now, once you have this and you work with this and you're comfortable with this, you can see that this has a very beautiful concept. Remember that io.inspect can take anything as input, output it, and return it as well. So here we can simply say io.inspect, and what this is going to do is whatever comes out of the sum is going to be inspected, and it's also going to be returned, which is going to go to the square. So now you can plug stuff in and you can debug the results, right? So let's go ahead and execute this, and you will see that we are getting the 9 out. So 9 is being output by io.inspect. If you want to inspect what the tail was, you can also put io.inspect over here, and you can see that tail is 2, 5, and you have 9, and then you have 81. So you have a free debugging tool in the form of io.inspect. Whenever you have a pipe operator, you can go ahead and after debugging, simply comment this out and you're back, right? So a very powerful debugging tool, plus your code is extremely readable, and that is the power of the pipe operator, and it is used extensively in Phoenix and in any Elixir project that you will find. So get in the habit of using this. It will make your code look a lot more professional.